After studying this module, you shall be able to know what speed tests are, know what power tests are, identify the difference between speed and power tests, understand the characteristics of speed test and power test, understand the relation of speed and power test to the standard deviation. Introduction. Psychological tests are classified on the basis of their performance, measurement, content, administration, scoring, and interpretation. On the basis of the rate of performance, the psychological tests are classified into speed test and power test. It is easy to distinguish speed test from a power test. On the one hand, where speed test assesses how quickly an individual can attempt the items of a test in the given time, the power test on the other hand assesses the difficulty level of items an individual can solve in sufficient time stipulated for the test. Speed and power tests both are designed in such a manner that it becomes difficult for any test taker to get a perfect score on the test. In this module, we will distinguish between a speed test and a power test and also establish a criterion to determine to what extent a test approaches a speed and a power test. The effect of incorrect or unattempted items on standard deviation will also be discussed. Speed test. In speed test, individual differences depend entirely on the speed of performance. Though the items included in the speed test are within the ability of the test taker and are of uniform difficulty, yet due to the time limit, no test taker will be able to attempt all the items on the test. The score of the test taker only reflects the speed at which he or she worked and not acquisition of knowledge. A pure speed test is a test composed of items so easy that the subjects never give the wrong answer to any of them. This implies that all the attempted items would be correct and the test taker's score would depend on how many items he attempts in the stipulated time, assuming that the test takers are instructed not to skip any item and they follow it. The clerical speed and accuracy test in differential aptitude test battery is one such example. Power test. Tests that have a long enough time limit to allow the test taker to attempt all the items are power tests. In power tests, the items are graded according to their difficulty level, starting from the least difficult to the most difficult, and the ability of the test is measured by the degree of difficulty of items that can be mastered with no time pressure on the test taker. Enough time is given to the test takers such that at least 90% of the test takers are able to attempt all the items. Some of the items included in a power test are too difficult for any test taker to solve, such that no test taker scores perfectly on the test. According to Gillickson, in a pure power test, all the items are attempted so that the score on the test depends entirely upon the number of items that are answered and answered incorrectly, assuming that none of the items are skipped by the test taker. Achievement tests are pure power tests. Characteristics of speed and power test. To understand the characteristics of pure speed test and a pure power test, we first need to understand the difference between two types of errors. Supposing W is the number of incorrectly answered items. U is the number of items not attempted. X is the total error score on the test. Therefore, X is equal to W plus U. Characteristics of pure speed test. In a pure speed test, since there are no wrong answers, W will be 0 and therefore mean and standard deviation of W will also be 0. Therefore, W is equal to 0, MW is equal to 0 and SW is also equal to 0. The subject's entire score is determined by the number of items not attempted, so X is equal to U. Hence, the mean of X and variance of X equals the mean of U and variance of U respectively. Mathematically, Mx is equal to Mu and Sx is equal to Su. Any test may approach to a pure speed test to an extent that the mean and standard deviation of W, that is MW and SW, respectively approach 0 and the mean and the standard deviation of U, that is Mu and Su, approach the mean and standard deviation of the total number of errors, that is M W plus U and S W plus U. As the speed factor of a test highlights the determination of the test score, it increases the odd-even method of the split half reliability, and hence this method is primarily used for part tests. Therefore, for a test to approximately satisfy a speed test, a criterion for a speed test should indicate the variability due to item difficulty or to carelessness in answering items is negligible. Characteristics of pure power test. In a pure power test, the score on the test depends only on the items that are answered correctly and incorrectly, as the time permits the test taker to attempt all the items. Hence, U will be 0 and therefore mean and standard deviation of U will also be 0. Hence, U is equal to 0, Mu is equal to 0 and Su is also equal to 0. Also, in a pure power test, the number of items incorrectly answered defines the total error on the score. Therefore, X is equal to W. Hence, the mean and standard deviation of X equals the mean and standard deviation of W. Mathematically, Mx is equal to Mw and Sx is equal to Sw. Any test may approach to a pure power test to an extent that these conditions are approximately satisfied. The odd-even method to find split half reliability is used in case of a power test. A test to being sufficiently close to a pure power test can be indicated by a criterion that ensures that any split half reliability, primarily the odd-even reliability, will not be spuriously high or low. Effect of incorrect or unattempted items on standard deviation. To understand whether the standard deviation of a test influenced by either the speed factor or the power factor. As we have discussed earlier, X is equal to W plus U, Mx is equal to Mw plus Mu. Representing Mx as X, Mw as W and Mu as U, the above equation can be represented as X is equal to W plus U. On squaring, summating and dividing both sides by n, we get summation x squared divided by n is equal to summation W plus U squared divided by n. On expanding, summation x square by n is equal to summation W square by n plus summation u square by n plus 2 summation wu divided by n, or Sx square is equal to Sw square plus Su square plus 2RW Sw Su. In pure part test, as all the items are attempted, Su is equal to 0. Therefore, Sx square is equal to Sw square. Consequently, Sx is equal to Sw. In pure speed test, as there are no incorrect answers, therefore, Sw is equal to 0 and hence Sx is equal to Su. It may be noted that Rw may be negative. In that case, suppose Rw is equal to minus 1, then Sx square is equal to Sw square plus Su square plus 2Sw Su. Sx square is equal to Sw plus Su whole square, or Sx square is equal to Sw minus Su square. Therefore, Sx is equal to Sw plus Su, or Sx is equal to Sw minus Su. It might be the case that 1. Sw and Su are larger than Sx, or 2. Sw or Su is 0, then either Su is equal to Sx or Sw is equal to Sx. Especially when Rw is equal to plus 1 or minus 1. When Rw is equal to plus 1, Sx is equal to Sw plus Su. When Rw is equal to minus 1, modulus Sx is equal to modulus of Sw minus Su. If Su by Sw is equal to 0.1, then 0.90 is less than Sw by Sx, which is less than 1.10. If Su by Sx is equal to 0.01, then 1.01 is less than Sw divided by Sx, which is less than 0.90. In the above situation, the test will primarily be a power test. Therefore, for a test to be a pure test, for a test to be a power test, Su by Sw is very small and hence 1 plus Su divided by Sx is more than Sw divided by Sx, which is greater than 1 minus Su by Sx. For a test to be a speed test, Sw by Sx is very small and therefore 1 plus Sw by Sx is greater than Su by Sx, which is greater than 1 minus Sw by Sx. Let's look at an illustration. Here, let us compare the speed component and the power component of the two subsets of the differential aptitude test, namely clerical ability and accuracy test and numerical ability test. To solve this illustration, we will first calculate the mean and standard deviation of the unattempted items, wrong items, and total number of error. These values will then be transferred to the formula for comparing as to which of the two components, that is, the speed component and the power component, is more dominant in which subset, that is, whether Su by Sx is greater than Sw by Sx or Sw by Sx is greater than Su by Sx. The standard deviations of the subtests of DAT for clerical ability test, Su is 10.94, Sw is 1.14 and Sx is 11.28. For the numerical ability subtest, SU is 1.41, SW is 4.06 and SX is 4.20. Therefore, for clerical ability test, SW by SX is equal to 1.14 by 11.28, which is equal to 0.11. SU by SX is equal to 10.94 divided by 11.28, which is 0.97. Therefore, SU by SX is greater than SW by SX, which means 0.97 is greater than 0.11. Thus, clerical ability test is a speed test. For numerical ability test, SW by SX is equal to 4.06 by 4.20, which is equal to 0.97, and SU by SX is equal to 1.41 by 4.20, which is equal to 0.34. Therefore, since 0.97 is greater than 0.34, SW by SX is more than SU by SX. Thus, numerical ability test is a power test. Through the above calculated statistical figures, it can be stated that for clerical speed and accuracy test of DAT, the ratio of the standard deviation of the unattempted items and the standard deviation of the total error on the test, that is SU by SX is equal to 0.97, is more than the ratio of the standard deviation of the wrong items and the standard deviation of the total error on the test, SW by SX is equal to 0.11. Hence, clerical speed and accuracy test of DAT is a speed loaded test, which implies that the test focuses more on the number of items the test taker can attempt in the given time period. On the other hand, for the numerical ability test of DAT, the ratio of the standard deviation of the wrong items and the standard deviation of the total error on the test, that is SW by SX is equal to 0.97, is more than the ratio of the standard deviation of the unattempted items and the standard deviation of the total error on the test, SU by SX is equal to 0.34. Hence, numerical ability test of DAT is a power loaded test, which implies that the test emphasizes the level of difficulty the test taker can attain. Let us summarize what we have learnt in this module. Tests may be grouped into speed test and power test and distinguished in terms of speed of performance and the difficulty of items respectively. A speed test measures the speed of rate of performance on a test in a given short time such that the score of the test taker reflects the number of attempted items and none can attempt all the items. A power test includes items in an increasing order of difficulty and enough time is given for the completion of the test, yet some may fail to do so because of the item difficulty. For a power test, Mx is equal to Mw, Sx is equal to Sw, and 1 plus Su by Sx is greater than Sw by Sx, which in turn is greater than 1 minus Su by Sx. For a speed test, Mx is equal to Mu, Sx is equal to S, and 1 plus Sw by Sx is greater than Su by Sx, which in turn is greater than 1 minus Sw by Sx. A pure speed test is homogeneous in content, the tasks being so easy that with unlimited time all but the most incompetent of subjects could deal with them successfully. The time allowed for testing is so short, however, that even the ablest subject is not expected to finish. A useful score is the number of correct answers made in a fixed time. In contrast, a power test contains items that vary in difficulty to the point that no subject is expected to get all items right, even with unlimited time. In practice, a definite but ample time is set for power tests. Speed tests are suitable for testing visual perception, numerical facility, and other abilities related to vocational success. Tests of psychomotor abilities, example eye-hand coordination, often involve speed. PAR tests tend to be more relevant to such purposes as the evaluation of academic achievement, for which the highest level of difficulty at which a person can succeed is of greater interest than his speed on easy tasks. In general, tests reflect unknown combinations of the effects of speed and power. Many consist of items that vary considerably in difficulty, and the time allowed is too limited to allow a large proportion of subjects to attempt all items.